And now let's take a minute to define place value. What is it? Where did we see place value here? How might we have used this image? Why was that different from when we saw it as this image? They're the same number of sticks. Why might it have been easier to see that quantity than when they were all lined up together in a row? What about once you got here? Did you notice these bundles? 2 bundles of 10 plus that 5, right? Now we can think of when we're in base 10, if we're bundling groups, quantities, loose ones in these sets, when we have a bundle, it's easier for us to recognize the quantity and actually more efficient. And now if we look at here, how many bundles of 10 do we have? How many do you think are in one of these? Hint, right? There are 10 bundles of 10, and we have 6 of them. So that's what we want to think about when we're thinking about place value. Place value is the actual, right? Think about the word place. Place is location. And value is the amount, the quantity. So place value is going to be the actual location of the numeral, or the numeral in the digit, and how much it's valued, how much it's worth. So, right, if a numeral is in the ones digit, it's now only worth 1. But if that same numeral is now in the tens, hundreds, thousands, millions, a different digit, now it has a different value. And that's really important. The place value allows us to now write an infinite, right, number of numbers. We have every single number in infinity, and we can use it, we can write every single one that we can think of only using these 9 symbols, 10 symbols, 0 through 9. 1 through 9 is 9, and add the 0 is 10. So we have 10 symbols, 10 numerals. And so that's really important, and that's because we're in base 10. So I want to reiterate that base 10 is going to be not only how many symbols we have 10 symbols when we're in base 10, but also how we create our place values. Each place value is created by bundling the units in that many groups. So in base 10, 10 to the 0 power, right? Anything to the 0 power is 1. And so we have, these are our ones column. And when we regroup, when we get to that 9 pieces, we now make a rod, or the second place value in our base 10 number system. We call that a 10. Now we regroup 10 tens now make 100, or our third place value, or I'm going to call it the flat, because we want to see in our other bases, it's not 10, right? It's not called a 100. There's not 100 in our flat. Right? There are literally 100 units, 100 little teeny tiny yellow cubes that make up this blue flat. Oops, sorry, here. And likewise, now we go to our fourth place value, or 1 bundle of 10. 10 bundles of 10 is our flat. And now we have 10 bundles of 10 flats, right? 10 bundles of 100 makes the thousandths place, or 10 to the third, right? 10 cubed. And so that same idea of bundling is very important when we get to the different bases. So in base 2, base 10 had 10 symbols and regrouped or bundled in sets of 10. Base 2 now only has 2 symbols, the 0 and the 1, and we regroup in sets of 2. So once we have a second cube here, right, we have 0, or then we get 1. Once we get a second cube, now we have to move over to our place value. Move over in place value to the second place value. Now our rod is only worth 2 in our base 2. And then again, once we get another rod, 2 times 2, right? We bundle in groups of 2, so we can have a 2 and then another cube. But as soon as we get 2 rods, boom, we make a flat, right? Just as soon as we got 10 rods here, we made a flat. We had 10 rods, so it made 1 flat, right? 10 tens is 100. Here, 2 twos is 4. That's what this 2 squared, or 2 times 2, right? As soon as we got to 4, we now had to make a new place value. This is a flat. And then, again, if we got 2 flats Here, once we got 10 flats, we made the cube. Once we get 2 flats here, we make the cube. So this is a 2 back, and 2 by 2 by 2, right? 2 tall, 2 left and right, and 2 front and back. So that's our 2 times 2 times 2, or 8. So now I know the phrase everybody likes to say is, oh, the world will shut down when 2 plus 2 doesn't equal 4 anymore. Well, guess what? If you're in base 4, or even in base 2, right? 2 plus another 2 is 100 in base 2. All right, sorry, think about that. Likewise with base 3, right? Base 3 is going to have 3 symbols now, 0, 1, and 2, and we regroup in sets of 3. Base 5 is going to have 5 symbols, 0, 1, 2, 3, and 4. And we regroup in sets of 5. So the number 5 doesn't exist in base 5. Just like the number 10, sorry, it keeps clicking ahead, doesn't exist, right? The 10 is just the reuse symbol of 1 and 0. So that's what I want you to think about. What does the base of a number system mean? It means the number of symbols it has and how you regroup in that base for those new place values. So base 10 regroups in sets of 10. Base 2 regroups in sets of 2. Base 16 is going to regroup in sets of 16. That's a hexadecimal system. And so if we think about other number bases, the ancient Mayan numbers, that regrouped in sets of 20. As soon as we got to 19, we filled up this whole bottom row place value. So we replaced it with the 0, the clamshell, and boom, there's our new place value. They did a vertical place value. So I wanted to now show this idea of grouping in the different bases with our virtual manipulatives. So when we're in base 2, I want you to see, as soon as, you can have more than 2 objects. You can have as many as you would like. But this is how we kind of convert numbers in how we think of them in base 10, a quantity, right? Because we're always living in base 10, we can't stop it. So this quantity of 2, 4, 6, and maybe I'll make it 7, is in base 10, 7, there are still 7 cubes. But if I look, that I can think about, well, 2, a set of 2, where did it go? I think I got to do this first. It disappeared. So a set of 2 automatically creates, sorry, I'm just figuring out, I'll turn that off. Oh, here we go. So if we look, a set of 2 automatically can group, right? And now we have 2 sets of 2, so we can regroup it again. And so now our 5, right? When we first, I know I had 7 at first, I'll put those last 2 out, and we'll think about the number 7 is 1 flat. And now again, we can put these 2 together, right? We're making groups of 2. So what started off as 7 cubes, 1, 2, 3, 4, 5, 6, 7, 4 plus 2 plus 1. In base 2, the number 7 is actually 1, 1, 1 unit, 1 flat, and 1 rod and 1 flat. 1, 1, 1, 1, which would be written as the number 1, 1, 1, 111. So 7 as 3 ones is also a little bit mind-blowing, and I understand that. But it's this idea of when we break these apart, right? When we have these individual pieces, when we're talking about whatever base we're in, we're just making groups of that base. So we keep grouping until there are no more groups to be made. So in this case, I grouped those 2. I made those 3 groups of 2, but now I have I can make another group of those last 2. And that's in base 2. Same goes if we're in a different base. Should we try base 4? So I'll put out, again, let's try 7 again. 3, 4, 5, 6, 7. So now when we're in base 4, we're thinking, how many groups of 4 can I make? So here, one group of 4, but now is this a group of 4? No. So if we're now thinking about it as place value, we have one group of 4 and 3. One rod, right? This is our second place value. So this is a 1 and then a 3. 1, 3, we would call that 13. Oh, I can type it. Here we go. Label. 1, 3. Right? One rod and 3 leftovers, 3 ones. We can do the same in base 5. We'll take our same 7. And now I want you to think about it. How many groups of 5 can we make out of 7 individual pieces? 1, 2, 3, 4, 5. So I can group these 5 here. And now our 7 in base 5, right? 7 quantity is 1 rod and 2. So here we have in base 5, we actually have 7 is the same as, which I know is mind-blowing, 12. That because we have literally 7 counters, but we have one group of 5 and 2 extra. That's how you can think about it. And I know why this is so hard. This is literally how our students feel, right? But now look, if we take that 7 when we're in base 10, right? Can we make a group of 10? No, that's why we just have 7 ones. If we had more than 10, let's keep putting some in there. Let's count them now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here's one group of 10. Let's group them together. And then we'll see how many do we have left over? 2. So that means we have one group of 10 and 2 left over. So that is, again, we're going to call that 10 because we're in base 10 and that's what we only know as numbers. But remember, 12 in base 5 was actually 7 because it was one group of 5 with 2 left over.